Thanks for attending. I noticed at the back of the room I couldn't see anything yesterday, so I went ahead and tried to push all of my slides up to the top. So if they look weird, that's why. Okay, so crowdsourcing Bluetooth information. So the about me is that I'm Xeno Kovah, and I think that the purpose of life is to solve problems. And I've been fortunate enough in my life that now I get to choose which problems I want to solve. And so the primary problem which I'm trying to solve right now is the fact that we don't have enough high-skilled engineers. To that end, I've started a nonprofit called Open Security Training, where we put out free, high-quality, exact same training that you're going to pay thousands of dollars for at conferences, and you still will pay thousands of dollars at conferences for it. But we also go and we put it online for free. So I generally find that there's kind of a disjoint audience in terms of the people who go take paid training versus people who take free training. So we still just want the best possible training available for everyone, so we put it online for free at Open Security Training too. So 25% of my time is spent then on research like I'm talking about today and just miscellaneous consulting, things like that, because basically open security training is like a multi-decade problem to be solved, and I need to have little problems that I can solve, because there's no such thing as workahol, but there is such thing as accomplishahol, and I am an accomplishaholic. That means I need little small problems to keep me going. And so that's what this Dark Mentor Bluetooth research is about, finding little problems and solving them. So for the purpose of this research, what do I want to know? I want to know what Bluetooth chip is inside any given device. So you've got Tesla's iPhones, Nest cameras, and door locks at hotels. What are they running? Well, I know already that they're running Texas Instruments, Broadcom, Silicon Labs, respectively. But for any random door lock, if I show up and I find out that it has Bluetooth, I want to know what kind of Bluetooth chip does it have. Now, why do I want to know that? Is because I want to know if it's vulnerable to firmware level exploits. So Texas Instruments, for instance, back in 2018, the first ever link layer low-level firmware exploit was found by Armis. And they basically said, over the air, send a magic packet, boom, arbitrary code execution in Texas Instruments firmware. Broadcom had a similar thing in Bluetooth Classic, and the CMU Labs group in TU Darmstadt in Germany, they found that vulnerability, and it applied to Macs and iPhones and stuff like that. Now, in 2020, my wife, Xeno Kovah, presented a similar vulnerability down in the firmware level of Texas Instruments and also for Silicon Labs. So basically, Veronica is a former NSA capability development specialist. And so she went off and started Dark Mentor and went off and did Bluetooth research and found vulnerabilities in 2018, 2019, presented them at Black Hat 2020. But the big problem that we had here was, okay, you've got an exploit. Where does it apply? What's the impact? And we didn't actually have any way to say that. And so since we have self-respect, we didn't make a big hyped up deal about it. We didn't say oh my God, billions of Bluetooth devices are vulnerable, which certain other venture capital funded type companies might. So basically, we've been working on this problem at a low level of effort. Like I said, mostly I'm doing the nonprofit thing, but a little bit behind the scenes, I've been working to try to pick apart, how do I know whether Veronica's exploits apply to a random TI device or Silicon Labs device? So in this talk, the terminology is pretty simple. BLE is Bluetooth Low Energy. Bluetooth Classic is the original Bluetooth circa 2000, 2001, aka the only thing that existed before Bluetooth Low Energy. And a BD-adder, which we'll see a bunch of, is a Bluetooth device address. It's going to look like a MAC address from Ethernet, but it's not a MAC address most of the time, although occasionally it behaves exactly like one. Okay, so previously, back in 2023, I started presenting about Bluetooth printing. This is Bluetooth tooth printing, because we're not fingerprinting them, we're tooth printing them. And so this was basically my first cut of attempt of just best effort, keep it simple, stupid, throw together a bunch of bash scripts and Linux tools and stuff like that. But it's been evolving, and so now I'm, a year and a quarter later on, and we've got a much better thing for identifying devices. Now, when it comes to data collection, we've got a bunch of different ways. You can have like just any random laptop. That's what I'm rocking up here right now. Just slap a Linux VM in it and then, attach some dongles. So this dongle right here is the Bluetooth Classic one. So if you don't have that dongle, you don't get arbitrary packet creation for Bluetooth Classic. Similarly, if you don't have some of these other ones. So there's the easy mode, which is just get a laptop, get some dongles that we mentioned on the Git repo, and then boom, you've got some advanced Bluetooth capability. There's the tiny collection, where basically it's just the Raspberry Pis. And so out of the box, just with a plain Linux on a Raspberry Pi, you do actually get both Bluetooth Classic and Bluetooth Low Energy. You just don't get the arbitrary packet creation, and there consequently you can't do as good a tooth printing job as you'd like to. But basically that's what I take around. It's smaller than a cell phone, depending on what thing you have. I take that around when Veronica doesn't like me taking the big old box, which is that one right there. She doesn't like it when I take that places because, it has the big battery packs have a tendency to look like, just there could be anything in there, C4 charges or whatnot. So she doesn't like that I run around with that. And quite frankly, I get in everywhere with that except Disney World. Disney World is the only place that's ever actually stopped me and searched my bag and told me to turn it off. Senate? Over here? No, like, Hackers on the Hill last year? No, they were cool with it. Just walk on in. But yeah, so you can go pro or you can go small form factor if you want less suspiciousness, or you can just go a laptop and put it around. I like this. Obviously, this is my favorite one because essentially I've packaged it into a waterproof thing, and then I go and I set these things. Well, not this one because it's expensive, the $620 one. Basically, you back up to this one and you put that in a box sitting over Highway 495 and stuff like that, and then you capture everyone driving by for their commute in the DC area. So yeah. All right, this is the only slide I couldn't really fit into the top half of the screen, sorry, but this is basically what the Bluetooth stack looks like for both Bluetooth Low Energy and Classic. And what I'm trying to show here is that Bluetooth has the concept of the host layer and the controller layer. Controller layer means the actual, usually it's like a dedicated Bluetooth chip. The thing with Bluetooth is it's weird and literally everything could all exist on a single chip, and therefore I could say a firmware level exploit could happen with all of these. But most of the time, this controller layer, which is the stuff below this host controller interface, that's supposed to be the separation there. Host controller interface is host, think of it like it's Linux. Controller, think of it like it's TI chip, Silicon Lab chip, Broadcom chip, and whatnot. And so Veronica's vulnerabilities back in the day were on the link layer of Texas Instruments chips and Silicon Lab chips. So anyways, where all should we inspect? We should inspect everywhere. Like collect all the data from all the layers and you can build a better tooth print from that. Where all do we currently inspect? Right now, this is basically focused mostly on the juicy core here. There's a lot of work, again, 25% of my time. There's more work that can always be done. I don't do file layer fingerprinting. There's a rich amount of work there, but usually file layer fingerprinting is more about like tracking an individual device over time. Like I want to track that one person. It's not about like this fingerprint equals a TI thing. I think there's probably going to be stuff there. But again, I'm not an RF engineer, so that's not really something I'm cut out to do. So I'm focusing on, firmware type stuff, as is my forte. So yeah, like all the middle stuff, this is the kind of stuff that tooth printing is currently collecting. And then there's a whole ton of things up here. This green stuff, these are what are called profiles. And in Bluetooth, profiles are essentially like combinations of protocols and stack layers and stuff like that. It's specifications on top of specifications on top of specifications. So the core stuff that you'll see, and the next talk we'll talk about as well, things like GATT, generic attribute profile, uses the attribute protocol. That's an actual protocol that has packets. GATT doesn't have packets in and of itself. It uses at packets, and then you have a profile which defines, what do those values mean. So that's the kind of stuff that I look at these days. And originally I wanted to have, a 50-minute presentation. So I was going to show you all sorts of cool stuff about like what the new features are, and I'll show you a bunch of anecdotes about, sniffing Embassy Row in DC and stuff like that. Unfortunately, no time for that today. So instead, we're going to focus on 3 things that make the new capability for crowdsourcing and make it effective. So the first one is called CLUES, Custom Lightweight UUID Exchange System, or schema is actually, that's a typo, that should say schema. So basically, I started organizing information like What kind of information would we like to know? There's a whole bunch of UUIDs, and these UUIDs, universally unique identifiers, they can exist as 16-bit values, 32-bit values, or 128-bit values. Consequently, there's a bunch of them that are defined in the Bluetooth spec itself, and then there's a bunch where essentially it's, dear vendors, make up your own, and specifically make your own to separate you from other people. It's a UUID so that it's your UUID, not the other company's. So clues is both a schema that allows me to have, decent documentation, like automatic generated documentation about what are we trying to say here, and it's also actual data of here's all the things that I've manually identified. And this has been pulled out of Bluetooth printing to put it into its own repo so that it can be used as a standalone thing. And yeah, this is what I just said. Basically, the Bluetooth SIG, they define a bunch of UUIDs, but there's all these other ones that are not defined, not known, essentially, like by anyone, unless you go out and reverse engineer them. So right now, clues is 382 high signal-to-noise ratio UUIDs, meaning I literally went in and found each of them and confirmed that it is what I think it is, but there are thousands of these to go. And I'm going to be doing automatic UUID extraction in the future, but I consider that tier 2 data because, as you can see from the actual definitions, and hopefully that zooms perfect. So basically, like that's, this is not rocket science, that's just a little bit of data. So it's not a big deal, but a UUID will be some unique thing like this, but then I need to associate that with a company. And obviously I said I care more about firmware and silicon vendors, but this could be any company. This could be Apple, Fitbit, Samsung, Google, and whatnot. So you've got a UUID, you've got a company. The purpose is actually a required field. So like, what is the point of this UUID? What do these people actually use it for? And in this case, this is used for device firmware update. So if you've got a Nordic chip, Nordic has specified this is the device firmware update UUID. You identify it based on the UUID, you connect to it, and then you perform over-the-air firmware update based on that. Now, this particular one gets the nice name of legacy or insecure device firmware update, because actually Nordic previously had a completely unsigned, unsecure, just ship bytes over the wire or over the air, ship bytes over the air to a device, boom, update your firmware. So that's like an easy, obvious, arbitrary code execution vulnerability. If you see a device that has this, you just need to know how to speak Nordic DFU protocol and you get to write whatever firmware you want to the device. Arbitrary code execution, no problem. That's easy mode. But the big thing for me is I'm a cites or it didn't happen kind of person. I like citations, and therefore I wanted to provide like, why does Xeno say that this UUID is what it is? And I not just provide citation, but provide archive.org citations, because these links break all the time. There were literally, as I was putting together clues, I had just a hobo like CSV file before that, and multiple links were broken already. I have some Amazon UUID information that I'll never get back because I don't know where to cite it. Anyways, that's like the basic of clues. So in the next stuff that you're going to be seeing, I'm going to be showing you Tell Me Everything output. This is the actual Bluetooth printing interface to the data. So Bluetooth printing takes a bunch of data from a bunch of sources, scrapes it up, puts it into the right data format, sticks it into a backend SQL database, and then we need to have a way to look at that SQL database in a reasonable human-readable format, and that's what Tell Me Everything is for. And so Tell Me Everything is using clues now to enrich its output. So we're going to cover some examples of like how we use clues with Bluetooth printing. So the first one, if we look right here, we have a BD adder for some particular device. I just randomly, searched for something. And I don't know which specific chip this is. Like my perfect world goal is I want to know like literally exactly which chip it is. I want to know which chip and which firmware, because then I can know whether it's a patched firmware against over-the-air exploits and stuff. But more often than not, I can't get to that level of granularity yet. More often, I can tell you at least the chip maker. So I can say which silicon is this thing actually, and I can pull that from multiple sources, not just clues, not just UUIDs, multiple sources, one of which is actually like there's two packets, one in Bluetooth Classic, one in Bluetooth Low Energy. These are version packets, and these actually include a company ID, which almost always is the chip maker. So essentially, there are very high signal places where you can extract this information. But anyways, this is just some random device that I pulled. It's called SmartU, and so maybe if I also have like a database of names, like name prints, essentially where I've Googled things and I say like this name equals that product. but I'm not that interested in products again. I'm interested in like specific chips. So smart U, maybe I'd be able to figure it out. But this thing turned out to be like the thing that like gives it away. There was a UUID in this thing's advertised information, actually not advertised in its GAT information. And the UUID didn't correspond to anything, but I have this other data from some academic research called BLE scope. I'm grateful that they provided me the data. And essentially, this is an association of UUIDs that existed in Android applications. And so this particular Android application, ch.details.lorastar, if you Google Lorastar and stuff like that, what you get is, it is a Bluetooth ironing board, apparently. So I don't know why that needs Bluetooth. I didn't really look into it that much. But yeah, so stick around for the next talk, because Remy has actually done a lot of work with UUID analysis in the context of Android applications. I literally haven't done any. I just grabbed the BLE scope data from them and slapped it in as another data source to analyze. So yeah, that's an example of some stuff we see. This is what all the GAT data looks like. It's not that interesting right now. It's got a bunch of UUIDs where I don't know what any of them are yet. But of course, obviously, we could enrich this with automatic analysis of saying, well, these UUIDs only ever exist in this one thing, which this one thing is, the Lorastar stuff. But the other little interesting bits here, so there in the GAT information is where we found the actual Nordic UUID name. But like some of the other stuff is this. So SMP, Security Manager Protocol, this is basically the stuff that has to do with pairing. And essentially, if you are not, there's a bunch of different modes for pairing, but basically Bluetooth specification, when Bluetooth Low Energy came out in specification 4.0, and Mike Ryan, another security researcher, found that, look, this is totally broken and anyone can brute force the 6-digit pins that exist, and consequently the Bluetooth SIG had to go back and completely redo the crypto and the security protocols to basically make Bluetooth Low Energy look like Bluetooth Classic, which already did it okay with Diffie-Hellman key exchange. But so basically there's a notion of secure connections and legacy pairing. And if you're using legacy pairing, you're guaranteed machine-in-the-middle attacks and or eavesdropping attacks. Like literally, they don't have to do anything. They can just guaranteed find your stuff. And so we can analyze things like SMP to find other vulnerabilities that exist. So we can say vulnerability 1. This thing is using the Nordic guaranteed insecure over-the-air firmware update. That's like a super bad vulnerability because it's an arbitrary code execution architecturally. But there's other vulnerabilities where if you really were concerned that this particular Bluetooth ironing board could have its traffic sniffed and stuff like that, well, then you'd start caring about this. But I'm more interested in the wormability of the vulnerabilities down at this level. So second example, Silicon Labs. Now, this again, just random thing. UUID tells me it's Silicon Labs. Go down, look at some of the actual data. This particular thing, I was able to get the actual data for. So basically, sometimes the tools will only be able to enumerate the stuff. Sometimes the thing will actually be able to read back data. This particular one shows up with a device name of Magic Band and a company ID down in the GAT information of Disney Worldwide Services. So this one is pretty clearly a Magic Band, which is an access control mechanism at Disney parks that allows people to get front of the line rides for things. This is how you skip the line, or I don't remember what it's called. I don't remember. But yeah, so Disney little magic bracelets have Bluetooth, and they have Silicon Labs. And that's what we have there. So Silicon Labs, again, I was keying in on the OTA firmware update. So Silicon Labs also has an over-the-air firmware update. There's gonna be a recurring pattern here that if someone makes a Bluetooth chip, they're usually going to provide a way to update the firmware over the air. So UUID firmware update. Now, what's interesting about this is that last year, August 2023, some Quarks Labs folks basically found that they could do an over-the-air exploit. So Nordic example I was showing you was like architecturally vulnerable, no secure firmware update. Silicon Labs is a architecturally secure firmware update that has digital signing and the things that you would want to see, but there's actually a vulnerability in the thing. So implementation flaw vulnerability. And actually what's interesting is it's literally the exact same vulnerability. If you saw the Renaissance talk yesterday about the secure boot vulnerability, now this is not actually secure boot, like they mistitled this talk. This is secure update. It does not have secure boot like enforced digital signature every single time the system boots. It's just enforced digital signature upon firmware update. But anyways, it's always the same thing. Basically, developers don't check the header type stuff, where basically you've got to have some sort of header to tell you where to verify the digital signatures on the actual firmware, and they fall over and get exploited because of that. All right, and then miscellaneous thing, there's also some Amazon UUIDs in here, which again we know and clearly can pull out because of clues. It'll tell us FE03 is Amazon, and there's transmit and receive. So what is that? Well, that is basically, I don't know, I Googled it, and there's some sort of device like an Amazon Echo display type thing, which in room will play games with your Magic Band and stuff like that. But, again, as an attacker, what I care about is we've got like some transmit and receive functionality on both the Magic Band and presumably the Amazon Echo thing. So attack surface identification. All right, final example, Texas Instruments, again, just picking on them and Silicon Labs because Veronica's exploits. This one we can tell it's Texas Instruments both because of the presence of a UUID and also because this is the case where the BD adder exactly behaves like a MAC address in Ethernet. And so it's what's called the Bluetooth Low Energy Public BD adder. And essentially the upper 24 bits is a organizational unique ID designed by IEEE. So basically you just know always these things are Texas Instrument things, and they also never change. They're never randomized like other BD adders. Consequently, they're always trackable. So digging around in this data, we see, okay, I got some information out of there as well. We got model numbers, we got serial numbers. So now we know, again, this could be trackable because of that. Serial numbers are unique. But then there's other stuff that tells us like HPE Aruba and OAD something for the software vision. And so what I care about in this case is, I've got to stop using that since it's going to get recorded. Over-the-air download once again, but way back I said that the first people to ever find link layer vulnerabilities were Armis, and a second half of the Armis, they actually found two vulnerabilities. They gave it a nice marketing name of Bleeding Bit. So Bleeding Bit was two vulnerabilities, one normal buffer overflow exploit at the link layer, and one, hey, OAD, the over-the-air update by Texas Instruments is just architecturally vulnerable, but Aruba happened to slap some security by obscurity in front of it to try to secure it a little bit, where they basically said, write a magic number to this particular GAT characteristic, and then, okay, now you have access to this architecturally insecure over-the-air way to just slap code on the device. So that's cool. We can know always if there's Texas Instruments over-the-air download, it's going to be vulnerable. But then we need to say, like, which things are actually, wow, are you kidding me? 3 minutes? Okay, cool. I don't have enough time. Gonna skip some stuff. I did start late, Okay. All right, let's skip clues. Let's talk about BTIDES quick. BTIDES is basically, it's again a schema to organize some information about all this Bluetooth stuff that we have. We have all this stuff. It's interesting in the Bluetooth space because we have PCAPs for over-the-air stuff, but another most common logging mechanism is called the HCI log. There's that host controller interface, and the host controller interface doesn't see the stuff that goes over the air, or at least not all of the packets. And the packets don't see everything that goes on in the host controller interface. So there's actually like two data sets that are semi-overlapping, and there's further information about like semantic hierarchies and stuff, essentially this GAT stuff. I'm going to hope that Remy talks about this more to give you more information about GAT. But GAT is basically like hierarchies of service, characteristic, service, characteristic. They're, hierarchies. So I would show you that. Don't have time. So the basic idea, though, with BTIDES is that we need ways to share information, because essentially what I saw was, Remy's tool had one particular JSON data format. Different tools called WAD have different JSON format. Older tools called Getacker and Beetlejuice, they have different JSON formats. So everyone has a bunch of different JSON formats. So what I'm trying to do is start like homogenizing the information so that we can all share information between different tools. So the BTIDES information, we can input stuff from HCI and PCAP, and we can get out the BTides and we can share the BTides. All right, now at this point, I wanted to actually pick on someone who's running a flipper device in here, like inadvertent audience participation. I'm not going to, but I'm just going to say, dear flipper people, stop using flippers at conferences. They use public BD adders. They're trackable. There's a thing called Wiggle where people upload information about all the Bluetooth devices they see. If they ever wander by your house, they're going to see your flipper that was at the conference at your house. They can start tracking you. Please stop using flippers with Bluetooth on at conferences. Okay, so final thing. Let's talk about the BTidal pool. This is basically BTides gives me now the capability to start actually crowdsourcing this information because yes, I can share it between different people, different tools, but I can also share it up to the server and down from the server. I've already uploaded a sample data set from a bunch of other security conferences over the last years. So you'll have the DistrictCon data here as well starting tomorrow. But basically you can get started and just pull data about Bluetooth stuff even if you haven't set up all the rigmarole of getting all the PCAPs and stuff going. And what it boils down to is just you check it out, you run a setup script to start things, and then you immediately start, tell me everything, query BTides pool, BTidal pool, and then just something. Search for a regex, search for a BD adder. So you look at the command options and you can just pull data down from the cloud server. All right, no flipper attack. Architecture is not that interesting. No one likes architecture slides. I don't like architecture slides. Look at it go, animations. All right, yeah, BTides obviously helps us there. Okay, so the second actual final thing is basically why not just use Wiggle? Wiggle.net, it's a thing for, essentially it was originally created for Wi-Fi crowdsourcing, and essentially it collects you information about BSSID, SSID, GPS coordinates. But from this you can basically see that the Wiggle dataset, Wiggle added support for Bluetooth crowdsource collection in 2019, I believe. But they essentially tried to cram the Bluetooth information into this schema, and consequently, there's not enough information in their database to do anything useful with it except, extract back out GPS coordinates. But I do like Wiggle, and I do use Wiggle, and I basically use it as my GPS collector these days. And so now I can essentially convert the data into BTides format, upload it to BTidal pool, and had I shown you the BTide schema, you would see that it's way, way, way more complicated than this Wiggle schema. All right, so with that, I'm out of time. The conclusion is, all we know about Bluetooth is we know nothing. There's not enough research going on here. We need more researchers, and we need more people collecting this information so we can see it from different sources. I'm limited by the conferences I go to, the places I run around to. So you can go play with this today. Important thing is that Dark Mentor will be releasing 5 days of free training on Bluetooth Low Energy to open security training later on this year. So it's basically going to be 1 day of Bluetooth printing, 3 days of Bluetooth Low Energy deep dive. We're going to walk all the way from the bottom of the stack to the top of it, and then 1 day about Bluetooth vulnerability hunting. So if you're interested in that kind of stuff, follow Open Security Training or follow Dark Mentor, and then you'll find out when the beta tests open up later on this year. All right, appreciate your time. Have a good one.